System design question that is for the Kafka and message queue. That is like RabbitMQ, I can say. We'll discuss about the how to choose a message queue, Kafka versus RabbitMQ. So first of all, we have to be like take one example for the Starbucks like database backup queue. Let's use our Starbucks example. Like there's a two most important requirement are like asynchronous processing and persistent. So in the asynchronous processing, the cashier can take the next order without waiting, and the persistent, so customer order are not missed if there is a problem. So message ordering doesn't matter much here because the coffee make offer make batches of the same drink. Scalability is not as important either since queue is restricted to the Starbucks location. So the Starbucks queue can be implemented in a database table like you can see we have a order, order sequence, order status, and updated time in the table. So when the cashier take an order, a new order is created in the database back queue. The cashier can take that another order while the coffee maker pick up new order in the batches. So once an order is complete, the coffee maker marker is done and in the marks done in the database. So the customer then pick up their coffee at the counter. So a housekeeping job can done at the end of the each day to delete complete order. That's those with the done status I can say. So for Starbucks use case, a simple database queue meet the requirement without needing the Kafka. An order table with the crude read, update, delete operation works fine. This is the basic simple example for the ordering for the messaging queue I can say. So the Redis backend queue, it is also a database back message queue and still require the development work to create the queue table and read write from it. So for a small startup on a budget that already uses the Redis for the caching, Redis can also serve as the message queue. There is a three-way to serve the message queue in the Redis: pub/sub method, list method, and stream method. So in the diagram, we have this three types, three category: producer, pub/sub, producer, consumer. In the list, we have a producer, consumer. Similarly, the sending the message way or creating the message way, I can say, little bit different from each of them. In the first one, you can say we have at most once delivery, no data persistence. In the second list type, we have at most one delivery, can be persistent on disk, and third, we can perform the consumer group. And the stream process, at least one delivery we have, can be persistent in the Redis RDB and can form a consumer group. So PubSub is a convenient but has a some delivery restriction. So the consumer subscribe to a key and receive the data when a producer publish data to the same key. So the restriction is that the data is delivered at most one. So if a consumer was down and didn't receive the published data, that data is lost. So also the data is not persistent on the disk. If Redis goes down, all PubSub data is lost. So PubSub is suitable for the matrix monitoring where some data loss is acceptable. So on this scenario, we have to be use the PubSub method when there is a loss of data will be not matter. And in the list one, we can say like in the list data structure in the Redis can construct the FIFO like first in first out queue. The consumer use the block to wait for the message in blocking mode. So the timeout should be applied. So consumer waiting on the same list form a consumer group where each message is consumed by only one consumer. As a Redis data structure, list can be persisted to the disk. And for that reason, you can use the list one. And the last one is stream one. Stream solve the restriction of the about to method like pub/sub and list one. Consumer choose where to read message. For a new message ID, I can see from the table. For the 00 reading from the start. So at a summary, I can say database back and Redis back message queue are easy to maintain if they can't satisfy our needs. Dedicated message queue produce are better. So we will compare this Rabbit queue versus Kafka. After this type of problem or scenario, going with this. We are proceeding for the RabbitMQ versus Kafka comparison. Why we have to choose Kafka? Why we have to use the RabbitMQ? On which scenario? On which requirement? And which case study? So for the large company that need reliable, scalable, and maintainable system, evaluates message queue product on the following like functionality should be good, performance should be good, scalability should be good, and ecosystem good. So this diagram I not have a diagram, but a simple diagram I here presented here. First of all, we have to like uh, what is the difference between the RabbitMQ and Kafka. There is a multiple component which make a difference from each other. I can say when we are having a RabbitMQ, it is written in the ER language and Kafka written in the Scala and Java. Protocol in the following, I can say in the RabbitMQ we have a AMQP protocol. In the Kafka we have a binary protocol over TCP. And the client API we are using in the RabbitMQ like .NET, Java, Ruby, JavaScript, Go, C, Swift, and Kafka we have a Java, Ruby, Python, Node.js. And message priority in the MQ we have, and Kafka we don't have. And there is a other major component which we can Google it, or we can get the more information about this comparison. For the ecosystem, I can say not as good as Kafka, RabbitMQ, but but Kafka is very suited for the big data. They supported for the big data and stream computing. So when we have a live streaming of the data, that time you can see Kafka is majorly used. So we have to be major focus on the how they work. RabbitMQ work like a messaging middleware. It pushes messages to consumer, then delete them upon the acknowledgement. This avoids the message piles up, which RabbitMQ see as a problematic. So Kafka was originally built for the massive log processing. It retains message until the expiration and lets consumer pull message their own paces. And language and API in the RabbitMQ is like I can say written in the ER language, which make the modify the core code challenging. Performance scalability, I told like Kafka is better than RabbitMQ. And last we can say log processing and analysis purpose. The like for the example for an e-commerce site with services like shopping cart, order and payment, we need to analyze the log to investigate the customer order. So this diagram you can see we have a ELK stack, Elasticsearch which is used for the index log for the full text search, Logstash we are using for the log collection agent, Kibana used for the UI for the search and visualizing the logs, and Kafka is distributed message queue. So this is a high level of implementation or idea about this Kafka versus RabbitMQ.